Notice that the graph has a negative slope. However, it does indicate that as you increase in depth, you also increase in pressure. This is a positive correlation. Water is very effective at absorbing incoming light, so the amount of light penetrating the ocean declines rapidly, is attenuated with depth. At 1 meter depth, only 45% of the solar energy that falls on the ocean's surface remains. At 10 meters depth, only 16% of the light is still present, and only 1% of the original light is left at 100 meters. No light penetrates beyond 1,000 meters. Plants use sunlight as their primary source of energy through the process of photosynthesis. Photosynthetic organisms in the ocean, like algae and phytoplankton, have to live in the well-lit surface waters called the euphotic zone. The euphotic zone is the upper part of the ocean that receives bright and clear sunlight. In clear tropical waters, the euphotic zone may extend to a depth of 80 meters. Sunlight does not penetrate deeply near the poles, so in these areas, the euphotic zone may be less than 10 meters deep. Turbid, muddy waters may have a euphotic zone of only a few centimeters in depth. The dysphotic zone is the water layer beneath the euphotic zone. In clear water, it may extend as deep as 800 meters. The dim blue light that penetrates in this zone is not sufficient to sustain photosynthesis. The photic zone is made up of the euphotic and the dysphotic zones. The aphotic zone is the water layer where there is no visible sunlight. Most of the water in the ocean lies in the aphotic zone. Some lakes are also deep enough to have aphotic zones. When sunlight strikes the ocean, some of it reflects off the surface and back into the atmosphere. The amount of energy that penetrates the surface of water depends on the angle at which the sunlight strikes the ocean. Near the equator, the sun's rays strike the ocean almost perpendicular to the ocean's surface. Near the poles, the sun rays strike the ocean at an angle rather than directly. The direct angle of the sun's rays to the surface of the water at the equator means that more energy penetrates the surface of the water at the equator than at the poles. Water absorbs almost all of the infrared energy from the sunlight within 10 centimeters of the surface. And this very shallow layer light is converted to heat, which can rise the water temperature and cause some of the water to evaporate. When winds and waves stir the surface of the ocean, heat mixes in to cooler water layers below. 90% of the sun's radiant energy is absorbed by the ocean waters. This heats up the ocean. Dark blue ocean waters reflect less than 10% of incoming light. The wavelengths at the extreme ends of the visible spectrum are attenuated faster than those wavelengths in the middle. Longer wavelengths are absorbed first. Red is absorbed in the upper 10 meters, orange by about 40 meters, and yellow disappears before 100 meters. Shorter wavelengths penetrate further, with blue and green light reaching the deepest depths. This explains why everything appears blue underwater. The colors we perceive depend on wavelengths of light that are received by our eyes. If an object appears red to us, this is because the object reflects red light but absorbs all of the other. So the only color reaching our eye is red. Underwater, blue is the only color still available at depth. So that is the only color that can be reflected back to our eyes, and everything has a blue tinge underwater.